What up? Precalc. Let's go. If we know a couple things, trigs of radians, not bad. First, trig of like an obtuse angle is the same as the trig function of the reference angle. Reference angles are the key. Been telling you that the whole time. Regardless of where your angle is located, what can happen is you can draw a triangle, and if your reference angle is all you care about, you find that sine's always opposite, which is always the y distance, the vertical. And it's opposite over hypotenuse, but the hypotenuse is always 1. So we don't really care about the hypotenuse because it's dividing by 1. So it's just the opposite, which is just the vertical. Cosine, adjacent over hypotenuse, which is just the adjacent, which is just the horizontal. Okay. Tangent, opposite over adjacent. And SOHCAHTOA, opposite, vertical, adjacent, horizontal, or you could call the vertical your y distance or your y coordinate on your unit circle. Your x distance, your x coordinate, y over x. Okay, so what we do, we find the location, pi over 4, 45 degrees. How do you know that? You know that by now. Or you could take pi, which is 180 degrees, divided by 4, 180 divided by 4, 45. You draw your triangle. Boom, you label the side lengths, paying attention to left, right, up, down. Sine, opposite, root 2 over 2. Opposite over hypotenuse, right? But hypotenuse is 1, so don't worry about that. That's it. Cosine, pi over 3. Where's pi over 3? 60 degrees. How do I know it's 60 degrees? Take 180 divided by, take pi divided by 3. You get pi over 3. Take 180 divided by 3. You get 60. So 60 degree angle, opposite, adjacent. Cosine, adjacent, over hypotenuse, adjacent, divided by 1. Negative pi over 6, tangent, tangents. Negative pi over 6, 30 degrees. 180 divided by, pi divided by 6, pi over 6, 180 divided by 6, 30. Boom, 30 degrees, root 3 over 2, negative a half, because I'm going down. Opposite over adjacent, y over x. Negative 1/2 over root 3 over 2, which is negative 1/2 times 2 over root 3, which is negative 1 over root 3, which is negative root 3 over 3. Why? Negative 1 over root 3, multiply the top and bottom by root 3, rationalize, negative root 3 over 3. Okay? Cosine, 3 pi over 4. Where's 3 pi over 4? Well, I know it's a pi over 4 away from 4 pi over 4. 4 pi over 4 minus a pi over 4. Here's 4 pi over 4. Subtract a pi over 4. Going that way. Pi over 4, 45 degrees. Subtracting clockwise, adding counterclockwise, right? So boom, 45 degrees. I'm going to the left. I'm going up. Left and up. Cosine, adjacent. Adjacent, horizontal. Boom. Pi over 2. All right, this is one of those extremes. Sine, vertical distance. I know it's like SOHCAHTOA, opposite. Opposite's always the vertical distance. For the extremes, it's better not to think about the triangles. You can. Opposite's 1, hypotenuse is 1, adjacent is 0, but don't worry about it. Vertical distance is 1. I go up 1 to get to that. Okay? Tangent 3 pi over 2. 3 pi over 2 down here. What do? I go down 1. Oh, you could also do the coordinates. x of 0, y of 1. I don't go to the left or to the right at all, but I do go up, x then y. Here I go down 1. I don't go to the left or to the right at all. Tangent's the opposite over adjacent. It's the y over the x. The y distance -1, the x distance 0. Can you divide by 0? No, you can't. Think about turning a division into a multiplication, like 8 divided by 2. What number times 2 gives us 8? 4. Okay. 0 divided by 1. What number times 1 gets us 0? 0. So we're allowed to divide 0 by a number. 1 divided by 0. What number times 0 gets us 1? Cannot be done. That's why we say it's undefined. Okay? You can't multiply 0 by anything to get 1. You're not allowed to divide by 0. 7 pi over 6. I know where 6 pi over 6 is. Add 30 degrees. Add a pi over 6. Yoink. Yoink. 6 pi over 6. Add pi over 6. Adding. We should be good with this. 6 pi over 6. Add. Counterclockwise is adding. 30-degree reference angle. Longer side going to the left. Shorter side going down. We won't have to draw all the triangles. I'm going to do like 2 more. Then I'm just going to go to like what we're looking for. All right? Sine, opposite, vertical, -1/2. 5 pi over 4. I know where 4 pi over 4 is. Add a pi over 4 right there. It's the 45/45, going left, going down. -√2 over 2, -√2 over 2. Tangent. Opposite over adjacent. This divided by itself, I'm just going to write as 1. It's a negative divided by a negative is a positive. It's something divided by itself. It's 1. Sweet. Another extreme, someplace where a triangle doesn't really help me, at pi. Now here's 0 this way. Here's pi. Okay. How do I get there? I go to the left 1. Or you could say that x distance is -1. I don't have any y distance. -1, 0. Okay? Cosine of pi. What's the horizontal distance? It's -1. Sine of -4 pi over 3. All right, I know where -3 pi over 3 is. It's over here. I need to subtract another pi over 3 or add another -pi over 3 right here. 60-degree reference angle. Sine, opposite. That's it. I don't have to draw all the triangles lengths. I know what I'm doing. I'm trying to find the sine. So, opposite. 4 pi over 3. I know where 3 pi over 3 is. It's over here at pi. Pi's 180. Add a pi over 3. Add 60 degrees. Adding this way. 60 degrees. Boom. Sine, opposite, vertical, this length, going down -√3 over 2. 5 pi over 3. 1, 2, 3, 4, 5. Or 6 pi over 3, which is all the way around at 2 pi. Subtract a pi over 3. Here's 5 pi over 3. 60-degree reference angle. Sine, vertical, vertical, down, -√3 over 2. 11 pi over 6. I know where 12 pi over 6 is. 12 pi over 6 is right here. Subtract a pi over 6. 30 degrees. Cosine, adjacent. It's going to be the longer side. Going to the right. 3 over 2. Cosine of 0. It's not 0. Because if I'm going to the angle of 0, I'm going to the right. I go to the right 1. My x distance is 1. My y distance is 0. I'm not going up or down at all. Cosine, adjacent, x, 1. Sine of 2 pi. Well, 2 pi, it's the same location at 0. Sines, up and downs, the verticals, I'm not going up or down at all. 0. Tangent, negative pi. Negative pi is right here. Maybe you want to work with the quadrants. I'm going to the left one. I'm not going up or down at all. Maybe you want to say, oh, this point here is negative 1 comma 0. Tangent's y over x. Y is 0 over x. Or you could say opposite, which is the vertical over the adjacent. Maybe do that. All right, secant. I'm going to find the cosine and flip it, because secant's the flip of cosine. Pi over 6, 30 degrees. Cosine, that guy right there, the adjacent, the horizontal, is going to be the longer side. Okay, so the cosine of pi over 6 is root 3 over 2. Secant of pi over 6 is this flipped. Rationalize by multiplying the top and bottom by root 3, you get 2 root 3 over 3. Cotangent, I think it's easier to know that tangent's opposite over adjacent, y over x. So cotangent's going to be adjacent over opposite, the flip. So cotangent's going to be x over y. 4 pi over 3, boom. Going down, I'm going left. There's my triangle. Cotangent adjacent over opposite. So I got negative 1/2 over negative root 3 over 2. A negative divided by a negative is a positive. So I got 1/2 times 2 over root 3. 2's cancel. I get 1 over root 3. Rationalize that puppy. Root 3 over 3. Cosecant. 7 pi over 4. Let's find the sine of 7 pi over 4. Where's 7 pi over 4? Great question. Well, you can either say it's between 6 pi over 4, which is 3 pi over 2, and 8 pi over 4. It's got to be 45 degrees. You do 8 pi over 4 minus a pi over 4. You can do 6 pi over 4 plus a pi over 4. Sometimes that works out. But this is good. I like that. 45 degrees. Okay, cosecant, reciprocal of sine. So the sine of 7 pi over 4. Well, the sine value is that vertical. I'm going down. So this is negative root 2 over 2. Flip it. Now when you flip it, you get negative 2 over root 2. This simplifies to just be root 2. You could rationalize and then cancel, or you could just think like this is root 2 times root 2 over root 2, like the root 2's cancel. I don't know. Whatever you want to do, just do it. Do it correctly. So get the right answer, root 2. If you rationalize root 2, get negative 2 root 2 over 2. 2's cancel, but cotangent pi. Pi over here. Sorry, negative pi. I'm going left 1, so the x is negative 1. The y, the up and down, is 0. Cotangent is x over y. It's the adjacent over the opposite. Adjacent over the opposite. Adjacent, opposite, the y. Not allowed to divide by 0. Cosecant 11 pi over 6. Found 11 pi over 6. It's a pi over 6 away from 12 pi over 6. Right there. There's 12 pi over 6. Subtract a pi over 6. 30 degrees. Cosecant. Flip sine. What's sine? Sine's the vertical. What's that? It's negative 1/2. It's the shorter side. Flip the shorter side. Negative 2. That's easy. Secant. 3 pi over 4. Negative 3 pi over 4. Well, I know negative 4 pi over 4 is over here. Add a pi over 4. I'm right here in the third quadrant. 45-degree angle. Secant. Flip cosine. Cosine, this length. Cosine, negative root 2 over 2. Flip it. You got that 2 over root 2. Simplifies to just be root 2. Right? You can write this as root 2 times root 2. Cancel root 2. Cotangent. Negative pi over 6. Adjacent. Opposite. That's 30 degrees. Cotangent is adjacent over opposite. It's the reciprocal of tangent, which is opposite over adjacent. So opposite over adjacent flipped, adjacent over opposite. Adjacent over opposite. Root 3 over 2 over 1/2. Root 3 over 2 times 2 over 1. Root 3. Oh my goodness, that's a negative. Adjacent, opposite, classic error, Mr. Messner. Secant 0. I know what the cosine of 0 is. Cosine of 0 is 1. How do I know that? Because I'm going to the right 1. Flip 1. You get 1. Hope we remember that if you flip 0, it's undefined. So let's see. What answer do we get 0? Sine 2 pi. If I asked you what is the cosecant of 2 pi, okay, if I ask you what's the cosecant of 2 pi, you're like, okay, I'm going to flip 0. I get 0? No. I don't get 0. I get undefined. You can take 0 over 1, flip it, you get 1 over 0. You're not allowed to do that. So understand that flipping 0 doesn't get 0. Flipping 0 is bad. That's your homework. You see this? 25, complete the unit circle. Again, with radians, degrees, coordinates. Challenge yourself to yeah, don't do this. Like, you could do it, but we're kind of like doing it as we do these problems. Okay, we're not referencing a unit circle. We just know like what's going on. We're not going to create this. I don't want you to create this because then you rely on this. So you're using your knowledge of triangles, radian locations to answer these questions, not a unit circle. So if you do this, good for you. It's just not required for me. Okay? Later.